Let's talk about the elephant in the server room, generative AI. Once hailed as a productivity savior, it's now becoming a cybersecurity nightmare, especially for small businesses. Generative AI refers to models like GPT-4, Claude, Llama, and GANs that use transformer-based architectures or adversarial training loops to generate original content, from text and code to synthetic audio, video, and biometric data. These models leverage vast corpora of structured and unstructured data and use deep neural networks with billions of parameters to simulate human cognition. They are capable of context switching, few-shot learning, and generating plausible but fabricated responses indistinguishable from legitimate data. Here's the twist. The same models that automate workflows and enhance customer support are being reverse engineered and fine-tuned by malicious actors. Cybercriminals now deploy generative AI to craft polymorphic phishing emails, spoofed internal directives, and business email compromises that are immune to standard heuristic filters. Let's go deeper. GPT style. Large language models use a self-attention mechanism to maintain context over long textual sequences. When fine-tuned on internal documents, they can replicate internal tone, domain-specific jargon, and sensitive formats like invoice templates or HR communication. This enables impersonation attacks that traditional anomaly detection cannot flag, especially if the threat originates from inside a VPN or approved endpoint. Then there's GANs, Generative Adversarial Networks. These consist of a generator and a discriminator in a feedback loop. The generator tries to produce realistic data. The discriminator attempts to differentiate it from real samples. This adversarial training results in outputs like voice clones and face swap videos indistinguishable from genuine sources. In security contexts, these are used to bypass voice authentication systems, fake Zoom calls, or mislead facial recognition systems with adversarial perturbations. A growing threat vector is prompt injection. Malicious actors embed hidden prompts within benign inputs, such as in metadata, images, or appended text strings, that hijack the model's behavior. These attacks exploit LLM's inability to differentiate between instruction and context. A support chatbot could be tricked into revealing database schema or issuing password resets without authorization. Next, data poisoning. By injecting adversarial examples into public or shared datasets, especially those used to fine-tune open-source models, attackers skew model outputs. For instance, subtly altering thousands of GitHub code snippets could train an AI coding assistant to recommend insecure functions under specific conditions. Model inversion attacks are another advanced threat. In these attacks, adversaries query an AI model to reconstruct sensitive training data. In one case, researchers extracted medical images from a model trained on anonymized patient records. These attacks are particularly concerning when models are trained on proprietary datasets and then deployed via public APIs. But genAI isn't all doom. It's also revolutionizing defensive cybersecurity. Security vendors are using transformer models to build autonomous detection engines that learn from logs, correlate threat indicators, and prioritize incident response. Platforms like Palo Alto's Cortex-XS IAM and Microsoft's Security Copilot harness LLMs to automate threat hunting, correlate disparate events, and accelerate containment. These models are especially good at building dynamic baselines of normal behavior for endpoints or users, performing real-time correlation of logs across multiple sources, enhancing SOC analyst workflows by summarizing incidents, recommending remediations, and generating compliance reports. Yet the attackers evolve too. They use AI to write polymorphic malware, software that rewrites itself on execution to evade signature-based detection. Some use reinforcement learning to adapt their attacks based on security responses, optimizing for evasion in real time. Small businesses are disproportionately vulnerable. Why? Because they often lack the infrastructure for endpoint detection and response (EDR). Network segmentation, dedicated red teaming and continuous monitoring. Role-based access controls on internal LLM deployments. So what must they do? Secure the AI pipeline. Encrypt training and inference data. Implement access logs and integrity verification. Use secure multi-party computation where feasible. Deploy PIDs. Use differential privacy to prevent training data leakage, federated learning to distribute model training securely, and homomorphic encryption to process encrypted data. Enforce zero trust principles, identity first access. No implicit trust within the network, constant verification, and least privilege access. Limit model scope. Do not allow general purpose LLMs unfettered access to business logic. Use domain-specific models. Restrict access via API keys, rate limiting, and behavioral logging. Integrate Hightail plus RLHF. Human-in-the-loop systems can override AI actions. Reinforcement learning from human feedback, RLHF, ensures models learn from actual security practices, not just training data. Test models adversarially. Regularly conduct red team exercises against AI deployments. Use adversarial examples, edge cases, and fuzzing tools to test model robustness. Monitor and patch continuously. Models drift. New threats emerge. Treat AI assets like code, subject to CI/CD pipelines, patching cycles, and rigorous auditing. In conclusion, generative AI is neither inherently good nor evil. It's a tool. But in the hands of threat actors, it becomes a force multiplier for deception, disruption, and data exfiltration. Small businesses cannot afford complacency. They must treat every chatbot, every AI assistant, and every generative model as both an asset and a potential liability. We are entering an era where digital trust is programmable and programmable trust can be hacked. Are you ready?